Well, good morning, everyone, and welcome to today's webinar. Odfjell's suction sails installation from concept to real-world results, brought to you by wind propulsion technology provider Bound for Blue. My name is Roddy Craig from Blue Sea in Oslo, and I'll be guiding you through today's conversation. And I want to say up front that we won't be discussing future hypotheticals or emerging technologies. We're going to walk you through a real-world case that's already delivering results, the installation of Bound for Blue's suction sails on the chemical tanker Bow Olympus, owned and operated by Norwegian shipowner Odfjell. You'll hear how Odfjell joined forces with class society DNV, engineering company Royal Roos in the Netherlands, and Bound for Blue to make the project fly, and how they tackled integration, compliance, and risk assessment. And to top it off, you'll hear firsthand from someone who's actually sailed on the vessel post-installation and his thoughts on that experience. So without further ado, let's introduce today's speakers. First, from Odfjell, we have Manager Projects Jan Opedal and R&D Manager Veine Huth. For the past 20 years, Jan has had multiple roles in the marine industry, on the class side as a project engineer at DNV and as technical manager in TTS Offshore Solutions. He's been with Odfjell for 5 years in his current role. In his post as head of R&D, Veine leads the company's drive to implement innovative technical solutions and vessel designs with a strong focus on energy efficiency and safety. And from DNV, we have Senior Principal Engineer Hasso Hoffmeister. Hasso has more than 30 years experience at DNV with the assessment of marine structures, sailing yachts, and rigs. And since the 2010s, he's been responsible for the development of the technical rules and standards for wind-assisted propulsion, ably assisted by a group of world-class experts. Then from Royal Roos, we have Director and Senior Project Engineer Andrés López, who is responsible for leading retrofit and energy-saving projects in collaboration with clients. And last but not least, we have David Ferrer, CTO and co-founder of Bound for Blue. Thank you for your presence today, gentlemen. Now, to make sense of this journey, we've structured the session around 3 chapters, which you can see on the slide. And in terms of practical info, we'll have a Q&A at the end of the session following the speakers' contributions. So please write any questions you have in the questions field, which you'll find by clicking the icon at the top right, the little rectangle with a question mark in it. And please indicate which speaker you want to address your question to. So let's dive in at the beginning and see how this journey all began, the why and the who. Let's start with you, Jan. What originally motivated Odfjell to explore wind propulsion? And when did you first make contact with Bound for Blue? The floor is yours.
Thank you. To answer this question, I think we have to go back to 2007, 2008, when Odfjell actively started working with energy efficiency. And we have mainly been working along 2 axes on this, on operational performance and improvements and technical improvements. On the operational side, we were quite early starting to collect the performance data from our vessels and making dashboards and business intelligence overview on this data. And that is really key to do any kind of improvements. You need to know where you are, you need to know where you want to go, and you need to be able to measure the improvements and the effect of the different initiatives you are taking on board. We also very early started with weather routing, taking the vessels into less waves. I think in 2008 we sailed an average wave height of 3.5 meters. Now we're around 0.6, so we've obviously avoided a lot of storms. And we have been very systematic in the hull and propeller cleaning, doing this around every 3rd month or so. On the technical side, we have done a lot I think we have invested around $40 million on 140 different energy-saving initiatives, ranging from MEVIS ducts to improve the inflow to the propeller, PBCFs to take out more energy from the pre-swirl after the propeller, reverse osmosis systems. I think we have on all the vessels now, as we have a huge demand for fresh water to clean our tanks. We have done derating projects of older vessels that are now sailing on lower speeds, and a lot of other stuff we have tested out. And this has reduced our CII from the 2008 reference line until today with around more than 50%. So we really come quite far. But what we see now is that the toolbox I've listed to you so far is running low, and we really need to up our game and to increase the risk and investments to continue on this trajectory to improve our emission profile going forward. And on this background, we consider sails to be the most promising energy efficiency technology to continue improving and reducing emissions. And looking into sails as a kind of a big family, we also see suction sails in many ways are combining the best features from rotor sails and wing sails. And we consider the Bound for Blue E-sails to be a very interesting alternative, both on CAPEX, OPEX, and the performance profile of the sails. I think we'll come back to that one. And to the last part of the question, I think we met up with the Bound for Blue first time in autumn 2002 on a conference in Gothenburg, Sweden. And then we signed a contract in June 2023. And after that and before that, we built a strong relationship between Bound for Blue and Odfjell, and especially highlight the role of David working out all the good solutions in this project. It's been really a pleasure.
Thanks, Jan. I mean, just staying with you for a minute. Could you also explain how you made your final selection of project partners, including Bound for Blue, but also Royal Roos and DNV?
Yes, Bound for Blue was selected after a relatively comprehensive comparison between all different sail technologies or families of sail technologies done by RISE in Sweden. They looked at all the relevant routes we are sailing, the actual polar plots of the different technologies. We looked into the cost profile and risk profiles of different technologies. And I have to say it was kind of close race between rotor sails and suction sails. I think they stand out as technologies in such a comparison. But in the end, we ended up with Bound for Blue due to the operational envelope. I think they have some real advantages in upwind conditions or wind close to the bow. There are less moving parts. They are lower on energy consumptions, and the time we also consider this maintenance and overall risk as beneficial with this technology. Also, based on analysis we did at the time, we found that this Bound for Blue suction sails provided the shortest return of investment. Royal Roos, we knew from previous projects, we worked together with them, and we really liked their approach to engineering and vessel integration, and we knew Andrés that we will meet later on, and he made a really good impression to us, and we were quite confident getting them on board that we would be able to find the good solutions for this integration together through discussions and challenging each other. When it comes to DNV, I think we have DNV class on this vessel, so I guess we were not left with too much choice partnering with them. But on the other hand, I think we have had a really strong relation over many years. I've been discussing wind-assisted propulsion with Hasso many times before we entered into this project, and they've been really supportive throughout the process and always available to clarify any issues and discuss any concern we would have. So I think the whole team mentioned there, it has been a true teamwork where we have challenged each other and yeah, made a good project in the end.
Yeah, thanks a lot, Jan. I have to apologise for an unexpected fire practice in the background. That's kind of typical, right in the middle of a webinar. But now turning to you, David, what made this project really stand out from your perspective as technology supplier?
Good question. Being honest, it's hard to point out just a single thing on this project. As this project, I think it is, and it will be key in Bow Blue growth and development. So just to put some examples, part of the strategy of Bow Blue was having a pilot or a demonstrator on a tanker. So this is obviously the project. We wanted to show that suction sails could be installed on tankers, and this project is showing that. We also wanted to partner with top-level owners in the industry, and that's why Odfjell, I think, again, is a very good example for that. They have brought us a huge experience and expertise and visibility, which is also important in this industry. This project is also allowing us to demonstrate that the installation of suction sails on tankers can be done in 2 steps if necessary. I will get back to that probably in a later stage. Basically, we did the transformation. Well, Odfjell did the vessel preparation wind ready during the 5-year dry dock, and then the sails were installed at a later stage. So we also wanted to show that this is possible and feasible. This project has also allowed us to validate, well, basically DNV has validated our methodology of calculating P-win. So probably the audience knows P-win is a very important factor to calculate the reward factor on fuel use. So being able to calculate it according to IMO rules and validate it, it's key on the business case because it brings a lot of savings. This project will also allow us to validate the performances with third parties. So another contribution from DNV is that they will be doing the third-party validation of the performances, and we think that this is key for the industry to trust and understand what are the benefits that our technology can bring. And just to point out one last important thing that I think it's also relevant is that together with Odfjell, part of the merit comes from them, we found a way of installing suction sails that are non-X proof, so non-ATEX rated, on vessels like tankers, which do have hazardous zones. And that's very important because you can install those sails without paying the surplus of making them non-X proof, so you get the best, the most cost-efficient installation. So to sum up, it is and it will be a key project in Bow Blue.
Great, thanks, David. And also Jan. So we've seen how the idea took shape and the right partners aligned. Now let's move into what it took to turn this concept into a working, class-approved installation. Sticking with you for a moment, David, can you please walk us through the full project timeline from feasibility to installation and explain what happened in each of those sections?
Okay, sure. This is just kind of the, let's say, generic process that every owner follows and that more or less this project also followed. So the first thing, and this sounds like very obvious, is that wind propulsion depends on wind. So it depends on where the vessel is trading. So the savings that you can get depend on the actual trading of the vessel. So it's important, the first step that we always offer free of charge to any owner is to do the preliminary case analysis to see what are the tradings for those vessels, what kind of sails can be installed on this vessel, and see if the business case makes sense. That was the first step we did with Odfjell. Also, they did a third-party evaluation with RISE, as he said. It's basically this step, understanding what are the benefits that you can get. Then we usually recommend to do what we call a detailed technical and economic feasibility analysis. This is just a concept design of the integration to understand what are going to be all the tasks needed to integrate sails on the vessel. So a first idea of the foundations, first idea of visibility, stability. So what do you have to do to get the vessel ready? And do a more detailed performance analysis, including more advanced models like, for example, introducing aerodynamic interference. That's also important to introduce. Then the next step, when you decide to move forward, it's to do the design of the transformation of the vessel and getting it approved by class. That's the key role where Royal Roos and DNV got into the project. That's the part they did. They did all the design transformation in a very efficient way, by the way. did a great job, as Jan pointed out. And this is getting everything ready to execute that transformation. And that's the fourth step. When everything is ready, you have to get your vessel wind ready. Wind ready means ready to accommodate the sails on. So this means installing the foundations, the cabling, and whatever other modification Andrés decided for your vessel. This is usually recommended to be done at a 5-year class 3 renewal because you're already on dry dock, so to avoid any extension of off-hire time, etc. So in this project, we did that. Odfjell did that in China during the 5-year class renewal. The foundations were installed, the vessel went out, and then you go to the last step, which can be done at yard or it can be done at a later stage, as we did in Odfjell. We did that in 2 steps. You install the sails, which is basically lifting them up, verticalizing, putting them on the foundation, connecting the mechanical connection with the bolts, electric connection to the sails, commissioning, and ready to go. And this was done at a later stage, as I was saying, in Antwerp, in Europe, during a short stay of the vessel at the EDR, at the yard EDR. And from there, the vessel should be ready to go.
Great, thanks, David. I mean, obviously, it's a very thorough process rooted in a solid operational business case. Now, let's turn to the engineering side. Andrés, can I invite you to share what were the main engineering considerations in the integration design of Bow Olympus, and how did you arrive at the optimal solution?
Yeah, sure. Thanks, Greg. I'm pleased to share these insights into the engineering process behind the integration of the e-sails on board of the Bow Olympus, this chemical tanker operated by Odfjell. The integration design for this retrofit was not a one-party effort. It required a multidisciplinary stakeholder approach. Our role was to align the inputs, expectations, and technical requirements from all the key players involved. We had Odfjell, our client. They initiated the project with a clear mandate, integrate for e-sails in a way that is cost-effective, safe, and compliant with all the applicable standards. Then we had the DNV, that was the classification society in this case, providing the regulatory framework. This was particularly interesting because e-sail is a technology that is relatively new. Then we have, of course, Blue, a manufacturer that brought this innovative product to the table, along with the specific installation and performance requirements. And finally, as installation was done in 2 stages, we have both shipyards that are responsible of the physical installation and need documentation, not only technically accurate, but also clear and practical for execution. So our job at Royal Roos was to act as the bridge between innovation and implementation, translating ideas and requirements into a workable, safe, and efficient design. But well, let's move to the core of the engineering process that was determining the optimal installation solution. That was not a simple task. We had to consider the vessel's layout, safety zones, structural constraints, and operational needs. To guide our decision making, our team developed a comprehensive feasibility study. The heart of this study was a decision matrix. In this matrix, we did evaluate 20 different potential installation positions and their combinations. Each option was scored against a set of technical and operational criteria. Let me guide you through the key ones for this installation. Vessel modifications, we assumed how much each potential position would require us to modify the vessel. The fewer modifications, the more feasible the option. Hazardous area clearance, as mentioned before by David, given that Bow Olympus is a chemical tanker, safety was paramount, and we had to ensure that the sails would not interfere with or require modifications to the hazardous zone on board. Structural integration, we did also analyze how each position would affect to the vessel structure and the modifications required for its installation. Most of the lighter position posed minimal structural interference, which simplified the integration process, in our opinion. Then the electrical integration. We checked the complexity of the routing for electrical components and cabling. That was, to be honest, relatively straightforward. This electrical integration is not of the playing not complexity for integration. And then we have the bridge visibility and sensor and antenna interferences. This was one of the most important aspects during the design process. Placing the sails too far aft could obstruct the cruise line of sight or interfere with radar and other sensors. We found that also forward positions minimize mine sectors and were therefore preferable for navigation safety standpoint. After evaluating all these factors, we narrowed the options down to the 4 most favorable positions of the sails. The final configuration was selected based on a balance of feasibility, safety, and performance. Once we had our shortlist, we worked closely with Blue, who conducted a detailed efficiency analysis to confirm that the selected positions would deliver the expected aerodynamic and fuel-saving benefits. This project was more than just a technical exercise. It was a lesson in collaborative engineering. We had to balance innovation with regulation, performance with safety, and design with practicality. And we had to do it while coordinating across multiple organizations, each with their own priorities and constraints. The successful integration on board of the Bow Olympus is a testament of what is possible when engineering is approached not as just a discipline, but as a collaborative process. In closing, I would like to thank to all the stakeholders involved, Odfjell, DNV, and Blue, and the shipyards for their trust and collaboration. And of course, thanks to our team, all my colleagues in Royal Roos for their dedication and expertise. This project is a meaningful step forward for a more sustainable and maritime future, and we are proud to have contributed to it.
Excellent. Thanks, Andrés. Obviously, a lot of work bringing together and balancing out all those technical threads. Really fascinating. Now, for the class perspective, Hasso, can you explain how DNV evaluated the project with a view to granting integration approval for the retrofit? And can you explain how that process unfolded?
Yeah, thanks. Well, first of all, there's a number of things to consider when installing wing propulsion systems. All of them are somehow addressed either in class rules or standards or in international regulations. So depending on the size and complexity of the sail system, the 3 major technical topics I would like to talk about, also because I feel they are the most often requested, are the following. So topic 1, and particularly on Bow Olympus, this was applicable, is the placement in hazardous zones. So where and how can sail systems be located even if they are non-X-proof rated? Well, if equipment is located entirely outside hazardous zones, the relevant IEC standard considers the risk of ignition to be sufficiently minimized. These zones that are defined are rather categoric and geographically assigned to the ship deck arrangement, the cargo area, and the arrangement of possible vent pipes and valves. The assignment of the hazardous zones is not prepared to accept a more direct analysis on possible ventilation by the use of simulation, which may be giving rise to a possible different dispersion of explosive gases or media, such as it is practiced in the offshore industry, for example. One particular specialty on chemical tankers is the arrangement of deck girders being mounted above deck, as they are considering limiting possible ventilation so that the so-called Zone 2 is incorporated, other than, for example, on oil tankers where this zone is limited down on deck level. That means that any non-X-proof equipment must be arranged at a comparatively higher vertical level. Topic number 2, I would like to talk about the navigational topics to consider. And the major topics here are the discussion about line of sight, radar blind sectors, and navigation lights. And we receive those questions most often. So SOLAS 5 Regulation 22 defines the visibility requirements from the wheelhouse. Obviously, obstructions like sail systems, which can be quite large, can violate the minimum allowance of the free outlook from the wheelhouse. This is obviously different from sail system to sail system, and also whether the system is tiltable or not, or foldable. And if vessel owners voluntarily opt for the additional class notation nautical to enhance their navigational safety on board a vessel, restrictions to the line of sight are even more strict. So for that case, one possible mitigation option is the addition of camera systems that can bring an additional element of safety to compensate for the loss of sight and restore originally ability for safe navigation. Further relevant items that need to be addressed in that respect is the positioning of navigation lights and radar equipment, which may also require to be rearranged, and this also requires flag state evaluation and approval. Now, the last and third most hot topic, so to say, is the structural integration. The location where to place the sail system on board a vessel is obviously subject to many different criteria. So it is the sail's aerodynamic efficiency. It is the placement considering hazardous zones, the obstructions from navigational point of view, the vessel's maneuverability characteristics, and last but not least, the structural integration, as you can imagine. On a chemical tanker like Bow Olympus with large depth deck girders, those seem to be ideal for actually for the direct integration of a WAPS foundation. So design loads from wind need to be considered, and also to a fairly similar degree, also inertia loads due to the sail system's weight on a ship in motion, mostly in rolling motion, as you can imagine. Further, integrating a foundation as a retrofit often requires to also screen the ship's global structural stresses to evaluate the right location or possible reinforcements. So it is quite an evaluation process, the placement of a WAPS on board a vessel. So perhaps in a nutshell, of course, there are more and other challenges. And for ship owners evaluating installing wind-assisted propulsion, I can only recommend to carry out a designated risk assessment to evaluate and address them all. In the case of Bow Olympus, all of that evaluation and approval work resulted in the issue of the design certificate for the Bound for Blue e-sail and the award of the additional class notation WAPS for Bow Olympus.
Great, thanks Hasso for those insights into those three kind of very commonly asked topics. For me, most interesting are those kind of navigational safety aspects. Very interesting. Now back to the ship owner, Jan. Can you explain what were the main lessons you learned from the process of making the vessel wind ready at the yard?
Sure. Actually, the wind ready preparations were carried out during the 5-year class survey at the Shangxi shipyard in China. The work was actually relatively straightforward. Of course, there is a lot of welding, a lot of steelworks, cable pulling, moving of equipment, etc. But all in all, it's kind of very conventional shipyard work. And as we see on the picture, we did prefabrication of the foundations, so they were welded in advance and then lifted on board the vessel for integration. We had no real big challenges during these works. Of course, it takes time. It's a lot of welding and work to be done. It's a painting. This is a stainless steel tanker, so you have to do passivization inside the tanks after welding, building up a lot of staging. So it's a lot of work to be done, but not really complex. A cost-driving part for us was this modification of the radar setup. We have to install 2 radars in the bow to have to avoid blind sectors for the radars. On a chemical tanker, so there's a lot of outfitting on the deck, so the deck arrangement is a challenge, and we had to move some tanks, etc., added some cost. Lately there's been congestion in shipyards in China, so the dry docking took some time. We also had a typhoon during the work hitting the area. But with optimal planning and enough resources, I think it's possible to minimize the extension of dry docking time during such installation. I think we ended up maybe a week longer than a normal dry docking, but I think that should be possible to reduce in the future. Of course, ideally it would be easier to install sails whilst the vessel is off hire in the dry docking yard, but I think we have showed through this project that it's also fully doable to do it in 2 steps, as David explained, making the preparation in 1 step and then installing the sails later in the 2nd step. So I think this is the main lessons learned from our side when it comes to the wind ready preparations.
Great, Jan. I think the message there for me is optimal planning well in advance.
I think that's a good summary.
Yes. Back to you, David. I mean, how would you say the sales installation went, and can you share which activities maybe were involved and how much time each required?
Yeah, once the vessel was wind ready, as Anne explained, she went back to commercial operation, and at the date it was decided to do the installation of the sails. That installation was done at EDR in Antwerp. So the first step was to ship the sails from Spain, where they were being manufactured, to the yard. That was done before the vessel arrival. Because the first step is to do the pre-assembly works, which is mainly installing what we call the top and bottom winglets. Is these 2 plates at the top and bottom that you see in the picture on the left. And that was done with the vessel still in commercial operation. Then the vessel arrived at yard afloat. So the sails were ready to install. So the first day, 2 sails were lifted and installed on the vessel. During the night, the vessel was shifted. The next day, the 2 of the sails were installed, and after that, the next days, the electrical connections were finished. The torque and the balls was set up to the required torque. Commissioning, incline test, and the vessel after that was ready to go. So it was a quite short process. I think it took about, in total, vessel there, about 5-6 days in total. Probably we will be able to reduce the total time with the optimized commissioning and cabling connection, but it's pretty fast. And we're pretty happy of the good collaboration between all parts. I think Bamper Blue, Odfjell, and all the partners there, including EDR. EDR did a great job. So it really went pretty smooth.
Yeah, thanks, David. I mean, that's quite an amazing story, really. I mean, with what seems like quite a complicated procedure, it really sounded remarkably smooth, as you said. Now let's move on from shipyard to the sea, and what happened when the Bow Olympus went back into service. Let's find out. So turning to you, Veine, I understand you were on board during the first voyage with suction sails installed. Can you share with us what were the early results?
Yes, sure. Thank you, Roddy. I was having the pleasure of joining the vessel sailing from Antwerp to US Gulf on the maiden voyage, together with a representative from Bamper Blue. And of course, when the first part of the voyage, leaving Antwerp, we had, of course, we were in a commissioning mode, sort of to say. We had some alarm to figure out and get the sails to operate stably. And also, we hit some really bad weather for the first half of the voyage. But during this time also, we saw that the sails were actually turning off because of too high winds. So we got to confirm that sort of part of the sails as well. But when we came to the middle of the Atlantic Ocean approximately, we had 2,000 nautical miles left to Florida Strait. And then we were experiencing really favorable weather with regards to the sail. And for these 6 days, we were actually seeing on average a reduction in fuel consumption at the same speed and draft of over 5 tons per day. So that was compared to the 6 years of historically performance data for the vessel. So for those 6 days, we actually saved 90 tons of CO2 just for those 6 days. And this was also confirmed on the sort of the return of the backhaul voyage from US coaster to Antwerp, where we experienced an average reduction in fuel consumption of 16% on the whole voyage. So basically, it was more than expected from our side, and we were really sort of impressed with what we saw. And we also did and are doing a lot of other very interesting observations. Like Jan mentioned in the start of this webinar, we also see and can confirm that the even with high angle of attack on wind off the bow, we see that the sails are producing thrust and they are functioning with a very large sort of envelope, as Jan said. And this, of course, gives us a very high utilization grade with the trades we have. And also we see in these observations that even though the thrust given, the theoretical thrust from the sails are not that high, only that little push gives us an increased propulsive efficiency, actually. So the overall performance gain is much higher than expected. And also, apart from that, we also, of course, saw on board, when you are on board sailing, it's quite a different story. We immediately could sort of see that the vessel is, how to say, more comfortable. It's moving much less, it's rolling less, it's much more steadily going through the water. And of course, this also reduces the dynamic added resistance of the waves, helping the vessel to perform even better. And also, it's more comfortable to stay on board, of course, in these conditions. And also, just to mention, as with regards to the crew and officer and on board handling this system, I'm really impressed with the guys we have on watch during our voyage. And it's very easy to use this system. It's more or less autonomous, right? But of course, the engagement and enthusiasm of the crew, I'm quite sure that is helping us gaining the actual performance that we have seen. And they are really enthusiastic. And actually, at breakfast, the guy on night watch, they came down and they immediately started discussing how much trust they had gained through the night. So it sort of developed into an internal competition on board. That was really interesting to see. And they were also quite disappointed if it was not that much wind. And that's quite the opposite of what we are used to on board. So it's really interesting to see this really enthusiasm from the crew. And just to emphasize that the technology is very important, but also the correct operation of the sails also are really, really important for the performance of the ship.
Great, thanks, Veine. I think 5 tons per day fuel reduction is pretty impressive, and it's great to hear about the enthusiasm of the crew in the handling, the ease of use, and also the fact that the ship is huge emissions reductions. I mean, turning back to you, Jan, can you just kind of give us some reflections now that the system's operational? Can you give us a little bit of an idea about what you particularly appreciated working with the Bound for Blue team, and also what's next for you?
Sure. Like the main reflections now after a few months with the e-sails on board Bow Olympus is that the concept of suction sails are working well. As explained by Veine, more or less from not day one, but at least week one, we saw real savings based on reference curves we have for this vessel. It's very evident that the concept of suction sails is working. And we see that this VAPS technology and suction sails in particular can bend the emission curve for shipping today. You can buy more or less off-the-shelf product, install it on board. It's a sound business case with the new EU ETS and FuelEU Maritime and upcoming IMO requirements, it's a sound business case and you can really make an impact on emissions. As mentioned by Veine, the system is autonomous, but you really rely on crew training and have a dedicated crew to operate the system and keep it operational. Still a new product in the market with some child diseases here and there and alarms, and we need to reset, etc. Improving every day, but you need commitment on board. The impact of having sales on board is very manageable. We have talked about visibility, but the feedback from the crew is that it is not really a problem in practical life. You see what you need to see. If you don't see it, you move 2 steps to the side and you see it. So practically, this is not a big issue. The impact on maneuvering and radars is also very manageable for the crew on board. They're getting used to it and they see no real issue on that part. And also we had some concerns on external stakeholders, but feedback so far from pilots and other terminals, etc., is very positive. We have not had any challenging questions and feedback on that side. When it comes to the Bound for Blue team, they are a really dedicated team coming into the maritime industry, wanting to make an impact and contribute to making our industry greener. And I think we have built over the time now a relation based on some mutual trust and trying to challenge each other in a good way. They are a young organization still, growing very fast, but I think they're eager to learn and about maritime industry and principles and open to feedback from our side. Looking a bit ahead, Odfjell made a sister vessel of Bow Olympus wind ready a month ago in China. So we now have foundations on one more vessel. We have not ordered any sales yet. We have an ongoing discussion with Bound for Blue about product improvements and how to make this product even more robust and fit for being on the open seas in 20 years. And of course, as Veine touched upon, we are verifying the fuel saving performance. We have some early indications, but we are also using DNV now to get a third party verification of actual savings to see that is not only based on some glances and gut feeling. And then we are working on this technical robustness and reliability of the equipment the coming months. But of course, there is an intention here with all the work we put down to have more sales on the sea in the coming years.
Great, thanks, Jan. It's really, really good to hear that it's a great concept that's working and how much you can make a real impact on emissions. Thank you all, gentlemen, for your great insights. I think now we can turn to jump into the Q&A session from the audience. But just to get the ball rolling, I've got a couple of questions of my own. And the first one goes to David. David, can you give us an idea about what's next for scaling wind propulsion across the industry?
Yeah, so what we see at Bound for Blue, and I guess that the whole industry or part of the industry is already seeing, is that in line with all these regulations, FuelEU, the IMO Net Zero Framework, never remember the exact name, wind propulsion will become a standard in shipping. So we expect a big growth and we have to adapt for that. So basically, as a company, we are growing as a team. So the team, as Jan mentioned, it's growing quite big with a big focus in operations, manufacturing, after sales, and also commercial, of course. We also increasing production capacity both in Europe and in China to be able to deliver on both sides of the world. So we really want to be ready in advance before, especially this IMO Net Zero Framework. We think it's going to be a big boom. Already FuelEU make a big boost to the interest in propulsion. I think the IMO will basically put everything left. So we want to be ready for that situation, which is going to be there in a couple of years.
Great, thanks, David. And a question for Andrés. Andrés, as an integrator at Roos, I mean, how do you foresee the widespread adoption of wind propulsion tech across all vessel types, or will it be limited to certain categories of ships?
Definitely, this technology is proving its performance, and we don't see any major inconvenience for safe integration in other vessel types beyond engineering challenges. As engineering company, our goal and slogan is make it happen. So ensuring successful adaptation across a wide range of maritime applications. Each vessel type presents unique structural, operational, and aerodynamic considerations, requiring tailor-made engineering solutions. I think that aerodynamic studies will play a key role in determining the efficiency of the sails and validating the economic feasibility of the implementation. With the right approach, I think that the ECL technology has the potential to become a widely adopted solution, contributing to a greener and more efficient shipping.
Great, thanks, Andrés. And now I'll take our first question from the audience. For David this time, let me read it out. I think you mentioned the ship was installed during dry dock, in parenthesis, required every 5 years. So how feasible is it to install the sails outside of this time? And is there a limit on which ports this can be done in around the world? And also, how long does the installation process take? Thank you.
Yeah, so as I mentioned, also Jan mentioned, the installation of this. So one thing is the preparation of the vessel, steel works, cable pulling, etc. Recommendation is doing it during the 5-year dry dock because you can be doing tasks in parallel. The sails can be installed at the same yard, same time. We have also done that. If everything matches, I mean, on the situation, for example, with Odfjell, the dry dock was done in China and the vessel was produced in Europe. There was also a time restriction there that the sail would not be ready at the time because the vessel was dry docking too soon for the sails to be ready. So there's a combination of you basically have to do the business case. What is more efficient? Transport cost, timing, etc. If you don't do that at yard, then you can do it at a later stage, as we did on this project. Vessel is completely afloat. It takes a few days, as I explained then. What you basically need, it's a place with a sufficiently large crane to put the sails on and a terminal or a berth area where you can where this operation is allowed to do, but it's basically lifting and putting it on the vessel. In that case, as I was mentioning, we did the installation in Antwerp because the vessel commonly goes to the ARA region, so it was very convenient to get there. But I don't have an exact list of where you can and where you cannot. But basically, the requirement is sufficient lifting capacity. You can rent a crane, a mobile crane, to do this operation, and you just have to find the right terminal or the right area at the port or at the yard to do it.
Excellent. Thanks, David. Now a question for Veine. Does Odfjell have frequent loading and discharging ports, or is the vessel trading more randomly? How much effort was done in terms of port acceptance? And in addition, is the air draft limited by bridges? Quite a lot in there to unpack.
Yeah, I'll try my best to answer. Of course, we did some due diligence with regards to the ports that we are most regularly traveling to, but we didn't see any restrictions based on that, basically. We know there are a few restrictions with regards to bridge heights, particularly in the US area around New York. But the sails, as they are now, we have installed 4 sails, and they are not increasing the air draft of the vessel. It's below the mast height. Of course, the highest point of the vessel is on a different place on the vessel now, but actually the configuration we have now has not changed the ability to trade the vessel any differently. So we don't see any big issues, and the ports we've been in US and Europe, we don't have had any issues. Even we had some discussion with the pilots in the US and some debrief after the voyage, and they really don't see any issues with the sales whatsoever, actually.
Yeah, can I just, there's a bit of an addition to that question. Was there any limitation of air draft in operation? And if so, was there any consideration of a folding deployment system for a taller sail installation? Maybe, I mean, maybe you could say that, and maybe David could say something about that as well.
Yeah, I can of course start. We had that on the table from the start, considering if we should go for higher sails with a folding system. But for this pilot project, we decided for the cost of simplicity and complexity and costs to actually buy the sails that were below the air draft that we had already, for practical reasons.
Yeah, just to add on what Veine was saying, in the end, it's a matter of again, the business case that you do your payback. If you, in this project, the limitation on the size of the sail was air draft. They are just right at the limit. That's why they are 22 meters and not 26. We have a model that's 26, but we keep it at 22 to avoid a tilting system. You can go with a different strategy, which is larger sails with tilting system, but that's going to be adding cost because the tilting system has an extra cost, an extra weight. It would be X-proof because it would be in the hazardous zones. So you have to, basically, it's a matter of cost versus extra savings. And in this vessel, we ended up in this with this configuration.
Tremendous, thanks. Now a question for our class representative, Hasso. Hasso, in the evaluation and design process of adapting wind propulsion on ships, what are the key technical lessons learned?
Yeah, thanks. Well, earlier I tried to highlight already 3 of the typical big topics, but perhaps on a more general level, we are all, and I hope you agree, we are all still first movers in this industry if we look at the installation so far and the size of the world fleet. And but we must all make sure to build a bridge between innovation and practicality. So figuring out whether wind-assisted propulsion systems are technically feasible is a key part of them up and running on ships. So the right technical choices actually depend on a bunch of things like ship type, size, whether the project is a new build or a retrofit. That is a difference also. The type of the WAPs, the targeted power levels that ship owners intend to install, but also the specific trade routes, which could be more or less favorable using sail technology. Actually, I think that effective risk assessment, I mentioned that before, effective risk assessment really underpins the development of WAPs, including qualitative risk assessment and adhering to established certification and classification standards and international regulations that are also still in development in parallel with the industry activities. So using proven industry best practice and adaptable framework allows all stakeholders to address both expected but also unforeseen challenges and risks, ensuring a smoother transition to wind-assisted propulsion in the maritime industry.
Fantastic, thanks Hasso. I think we've got time for a couple more. This time to Andrés. Was there any consideration of carrying out inclining experiment and lightship weight measurement at the time of the Chengxi dry docking at wind ready stage for shortened WAPS installation at Antwerp?
It was not considered to do the inclination test at that stage. It was decided after a class requirement to perform it after the integration of the sails in the second stage. When doing the vessel ECL ready, we did not exceed the limits to for requirement of the performance of the inclining test. So at that point was not required. Thinking that executing that test at the stage 1, when the vessel is ECL ready, it will not provide most probably the results that you expect after an inclining test with the ECLs installed. But it's something maybe to develop and discuss with class in the future.
Great. Still time for a couple more. David, how are the new Fuel EU Maritime and IMO Net Zero framework regulations and the potential adoption of clean fuels affecting the adoption of wind propulsion?
Well, so 2 points here. One is how Fuel EU and IMO Net Zero framework affect or impact the adoption of wind propulsion. I think it's clear and obvious. Wind propulsion is considered as a clean fuel, so it provides a reward factor, so it improves your GHG index, so it has a huge economic impact or benefit on this rule. So I think it's key on the adoption. I think on wind propulsion, it's basically driving. It's one of the main assets. We've done case analysis in which just by including Fuel EU and EU ETS, you divide by 2 the payback. So it has a huge impact. And that's only Fuel EU, which corresponds to Europe. But when you expand that to the rest of the world, it's going to be dramatic for the owners and very positive for wind propulsion suppliers. Then concerning clean fuels, I sometimes hear kind of a misconception saying that as soon as we get clean fuels, that's going to be the solution to meet the rules, and wind propulsion will no longer be interesting. And in the end, it's a bit surprising, because in the end, wind propulsion, it's basically saving fuel tons. So the more expensive the fuel is, and we know that clean fuels is going to be expensive, the better the payback is, and the more interest you have on putting sails on. So we see wind propulsion and our e-sails as kind of an enabler of these clean fuels, because it allows you to need less tons of this new and very expensive fuel, so it makes it possible to actually use it with commercial sense. So I think both the regulations and the adoption of clean fuels are just basically benefiting the adoption of wind propulsion.
Great, thanks for that input. And last question goes to Jan, and what a nice question to round off with. What advice, basically, would you give to other ship owners considering wind?
I think I would just give them the advice, go for it. For us, it seems to be the right thing to do at this time. Go for it, and as Hasso is saying, do a thorough job evaluating the integration on your vessel and also different sail technologies, and be open. I think we are quite confident with the choice we have been doing, but there might be other answers for the other owners. So, but I think wind assisted propulsion is the right thing to do.
Great, that's excellent. I'm sorry, time was limited, so we weren't able to get through all your questions. There's quite a few in the box, but we'll send you answers in the next few days. So just hang on for your answers. They'll come from Bound for Blue and the other participants. So let's do a bit of a recap as we're nearing the end of today's session. It's been a real world look at wind propulsion, not theory, but actual results from Bound for Blue's suction sails in operation on the Odfjell tanker. And from early feasibility, this is my takeaway, from early feasibility to engineering, class approval, and the real fuel savings. It's a project that proves that wind isn't the future, it's already happening. Now, if you're curious about what wind could do for your fleet, reach out to Bound for Blue at inquiries@boundforblue.com. And if you'll be at North Shipping next week, make sure and go to speak to the team in person, and they'll be at stand TO3-26. So really all that remains is to thank our esteemed panel for their insights, and to all of you for joining, of course. And you'll soon receive the session recording video and a short survey to share your feedback. So that's it. Thanks, and have a great day. Cheerio.